Now we got one more thing to talk about. And we'll talk about it a little bit conceptually. It'll be fun, don't worry. Lying. We're going to talk about the Galilean transformations. Okay. So when Galileo was 13, he started to notice some changes. Oh, no, wait, that's wrong. No, it's about motion in different reference frames. I was in the wrong class, sorry. Different reference frames. Okay, so for this, what we're going to do is focus. We're going to try to focus. See if we can focus. Too many toys, we can't focus. Okay. We're going to focus on where Hal is. Hal is just sitting there. And at first, he's not even going to move. Hal is just going to sit right there. You're seeing Hal over here. Okay, now we're going to put him over here. Trying to make it match my notes here. Oh, I also have to turn this off or the magnet melts. Hold on. Oh, okay. Okay, let's see. So we're going to think about how do we transfer from one frame of reference to another. Okay, that's all we're going to think about. And then we'll do a quick problem on how this works. So what you got to realize is every object can, in principle, have its own Cartesian reference frame, its own Cartesian coordinate system, or with a center on itself. Right? This is a very me-focused kind of a thing. This is my coordinate system. It always follows me around. I don't care about your coordinate system. So I'm going to be a Cartesian coordinate system right here. And we're going to do x and y like along the floor. So we're not thinking about z. Now x and y means like this. So now you're looking down. Right, so here's the bench here, right, that's the big wooden thing there, and relative to me, here's Hal over here, right, and I'm standing, say, about right here. So this is the JH coordinate system, okay, and that's Hal over there. We'll call that, I don't know, I forgot, Hal, yeah. Okay, so my coordinate system looks like this. Here is y, and here is x. And everything that you would describe in my coordinate system, you describe relative to where I'm standing, right here. I mean, I'll try to stay in one place, right? So this is the origin. It'd be a vector going like that. So we also have Hal as an object. I don't want to draw him too weird, right? Hal as an object. So we want to describe Hal in two reference systems, okay? So we need mine here, and we need yours in the white jacket. What are your initials? MD. Okay, so MD. Is that funny? I don't know. Okay. Because you're pre-meds? Is that why it was funny? Okay. It's like, I don't get it. Okay. So here's MD. Right? So MD has her own coordinate system. Right? So I'll draw it dotted like that. Because mine is the solid one, and yours is the sketchy dotted one like that. Okay, so there you go. So there is her Cartesian coordinate system, right? So I want both me and MD to think about where is Hal. Like, which direction is Hal, where's Hal sitting? So now we're going to draw three vectors, okay? We're going to say, first of all, where is Hal in my coordinate system? Okay, so we're going to say R, and I'm going to write the notation looks like this. Hal, which is the object, dash JH. And that is the position of Hal in the JH frame, right? So that vector looks like this. Oh, it's a position vector. It starts at the origin, and you draw it up to there. That's R, Hal, JH, right? But then MD, now this is awkward because I don't actually know your name, and I'm calling you MD, says, no, it's not there. It's like in the negative x direction, or the negative y direction. So MD would say, no, it's here, like that. That's R of Hal. The object goes first, and the coordinate system goes second, right? R, Hal. Oh, wait a minute, I'm sorry. Wait, hold on. No, let's not look at that one yet. Oh, I got this all screwed up. I forgot how to do these problems. Hold on, what am I saying here? R, Hal, and position coordinate, blah, 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 blah. Blah, blah, blah. I'm going to add this plus this. I think I just want to describe all of them. Yeah, no, that was okay. Redraw that, sorry. Okay, so this is Hal in MD's position. So the position of Hal in MD's frame. Right? Yes, okay, I drew the right one. Okay, sorry. R of Hal in MD's frame. Right, okay. So the third vector is where is MD relative to me? Right? Our coordinate systems are related by this vector. Like that. R of MD in my frame. Right? R of MD in JH. Right? Position of MD in the JH frame. So you draw those three vectors. And there's no arbitrariness about which way they go. They're all as clear as they can be. The object of Hal in JH's frame must come from the origin of JH and go to Hal. Right? Hal in MD's frame must start at the origin of MD's frame and go to Hal. And then MD in my frame must start at the origin of my frame and go to MD. Right? That's how you would draw those three critical vectors. Okay? And now it looks like, if you look at it, it kind of looks like a vector sum, doesn't it? It looks like we've added the top two to get the bottom one. Looks like a vector sum. It looks like we've said R, let's see, what does it look like? Hal, JH. Oh yeah, no, that's right. It looks like, right, R of Hal and M, got the order different. Yeah, of Hal in MD's frame, right? That's that first, that vector. Shit, okay. Let me just not look at my notes. Let's just do this. It looks like a vector sum, doesn't it? It looks like R of MD in my frame plus R of Hal in MD's frame, right, equals R of Hal in JH's frame. Yeah. Yes, that's what it looks like. Right. Sorry, that took me 4 minutes. That would I would expect you to figure out faster than what it took me. Sorry. So that's the sum. That looks like a sum. Okay. So now what I'm trying to get to is to think about how you can always convert. Okay. So how to convert. So say this is an example where we knew the position of Hal in MD's frame, and we know R relative, but the question is, what is Hal in my frame, right? So you know, say you know R, say you want, you've got to write what you want. Want Hal in my frame, the way I drew it, okay? That's what you want. You want Hal in my frame. Forget everything I've said, just write it down, and it'll make sense later. You want Hal in my frame. What you do, and you say, okay, what I want is R of Hal. The object goes first and the frame goes second. Okay? So what I'm trying to show you awkwardly here is you don't have to draw any vectors. You don't have to draw any diagrams. You just have to follow a rule. Okay? Here's the rule that I was awkwardly trying to get to. Is first you write this one. You say R, the position vector of Hal in something, plus the R of the something in my frame. That's all you write. And what is the something? The something is the other frame. Right? So we say, oh, Hal in MD, MD in JH. Right? That's how you'll always get it right. Okay? If you try to do it in your head, you'll usually get it right because you're really smart. But sometimes you'll screw it up. Okay? Because there's negative signs involved and it's two-dimensional. It's easy to screw up. But this is a general rule. If you ever want the position, like in a problem, it says, well, what is the position of Hal in this frame? And you weren't given that. You just set it up like this. You say, well, if I want this and this, I have this and something in this. And now go back and look at the problem and you realize, oh, wait, I had Hal in this frame. And then you realize you had that. And then you can still do it. Okay? So all that was just to get to that simple rule. Is all I was really trying to get to. Right? So A, B, A, something, something, B. That's all that is. So now let's look at what we can do with it. All right, here we go. Let's do something with that. Oh, I forgot to say, if y'all were confused by that one board, if you 0.4 was negative, that fixes everything. There you go. If you don't know what I'm talking about, don't worry about it. But if you notice that, that fixed it. Oh, everybody flips back, yes.